Alright, so we finished the basic effect. So now let's build our particle system. So the particle system, I'm going to push it using, or I'm going to move it using a custom volume velocity. And the reason for doing that was primarily just to throw in something new or something extra. So you get an idea of how to build custom velocities to drive particles, or you can even use it for like pyrosims or fluid simulations and stuff like that. So the way to do it is take a box, okay, and this will contain our volume velocity, and I'll make it relatively big. So I'll make it about, like that big. Okay, and then we need to generate points on the inside. So I'm going to take an ISO offset. So just to turn it into a fog. You don't need to do anything with it. I can just give it a little more sampling divisions, and then take a scatter. So just do a scatter and turn off the relax iterations and just increase the points to a fair bit. Then take an attribute warp, and we're going to generate a velocity for this. So call it point velocity. Okay, so just come into the velocity, and this is fairly simple. Like, you don't really need to do too much. So I'm going to take a curl noise. You can take a turbulent noise as well, but we'll just take a curl noise and connect the position. And I'll just make sure that this is kept to 3D noise. Okay, like it is default kept to 3D noise anyways. I'll connect it to color so we can see it, and then just connect it to velocity. That's primarily it. Okay, I can lower the frequency a little bit. You can promote some of these parameters. So I'll just promote the frequency and the offset and the roughness. Okay. And now if you want to visualize this, okay, so firstly we need to convert this into a volume velocity. Okay, or convert the whole thing into a volume. So take something called as rasterize, and you'll find something called volume rasterize attribute. And this is an attribute called V, which is the velocity. Okay, so just connect this in and say the attribute is V, and there you go, you'll get that. Now make sure that you change the filter from Gaussian to point, because Gaussian tends to blur it too much. So make sure that you keep it to point. That's primarily it. Now, if you want to visualize this, so that you can, the nice thing about doing it this way is that if you can visualize it, you'll know exactly how the particles are going to flow. So you can sort of move the noise around and, actually get some kind of control over it. So just take a small sphere and we'll scatter some points on it. And then take something called as volume trail. So the volume trail requires two things. It requires the velocity volume and it requires the points. So plug in the points, plug in the velocity, and there you go. That's basically it. So you can just increase the trail length to see how it's going to spread. Okay, so this is how our particles are going to go. And you can sort of control a little bit here. But yeah, so if I come in here and I kind of move this around, you can get different results. So you can see exactly how the particles are going to move. Anyway, this is just for display. This is not going to affect our simulation, but it's a nice way to just visualize it. Okay, so now we want to start emitting our particles. So what you do is come to the delete, like this point, and plug this into a pop network. And the volume over here goes into the second input. Okay, so if I'm not wrong, this has velocity as well. Yeah. Okay, so we did this thing here, which is at V is equal to at N. So if I jump in here, and if you play this, you should start seeing something immediately. See, there you go. So they'll kind of just move out. And what I'll do is I'll just take the inherent velocity and make it really low. Okay. If you just wanted to move without the volume velocity, you can take a pop force. Yeah, so you can take a pop force, and what I want to do is I want to move it slightly upward. So I'll give it about 2 in the y-axis and then just give it some noise. Okay, like this is all for noise. So if you press play here, you'll get, this thing happening. But what I also want to do is I want to lower the life of the particle, because the basic lifespan is kept to like 100 seconds. So we'll bring it down to 2, so which is 2 seconds, that's 48 frames. And we'll do a variance of 0.5. Okay. And then I want a little more particles. So constant activation means on a per second basis. Impulse activation is on a per frame basis. Okay, I think. But anyway, so like make the constant activation 0. Impulse activation you keep to 1, and we'll take about 500 particles. And so if I press play, I should get, something, and then take a drag. So take a pop drag. I'll just drop it in the middle. And if I press play, I should see something slightly better. Yeah, perfect. Okay. So now let's take in let's remove this noise. I want to still push it upwards, but we'll remove the noise from here. And then take something called as advect. So you'll find something called pop advect by volumes. Okay. So drop this in here. It will say what is the velocity source. So we want the second input. And that's pretty much it. Okay, so let's just play this once and see what we're getting. Okay, let's do one thing. Let's take the velocity scale and increase that. Let's bypass these guys temporarily. Okay, so the reason why nothing is happening is because the field name is kept to well. Okay, and our field is called V. Okay, so just make sure you change this to V. And now let's press play and we should see something happening. See, there you go. So now what I can do is I can bring back the pop force to make sure that they get pushed upwards. Yeah, okay. And let's also do one thing. I want to come back here to my volume trails and take the point velocity slightly lower. Yeah, I think this looks nice. So yeah, this is the reason why I'm using a custom velocity is because you can visualize it this way. So if I press play, so it is a little bit more easier to sort of just, visualize how it's going to go. Okay. And then let's also bring in the drag. Let's try to increase the air resistance, see what we get. Yeah, there you go. See, so the air resistance makes sure that it will sort of stick to, those paths. So the higher that value is, the more it tries to stick to, the volume trails that are being generated. See, there you go. Yeah, so this is nice. So let's just increase the particle count a little bit. I'll make it say 1500 and we'll press play. Yeah, so there you go. Now, one thing I want to do here is I want the particle emission to start a little later. Okay, so I'm going to take a time shift and I'm going to push it back by 2 frames. So take the $f and do -2. So whatever value you subtract it by, it will get pushed back by those many frames. So essentially what will happen is if I look at this animation here, it'll start a little bit later. Okay. Okay, now another thing we can do here is I just want to give it some color, like some basic black and white color, so I can use it later. So I can just take a color here. So just take a pop color and set it to ramp, and by default it goes to a ramp called n age, okay, which is basically the normalized age. Okay, so I can just leave it at this, like I don't need to do anything with this. All I want is like a black and white gradient going through it, so I can use it later for coloring. Okay, so that's basically it. Okay, so this is done. Now the final thing left is to make the trails. Okay, so that will split up separately. So what I can do firstly is I want to take a color node, and I can just come in here and we'll say ramp from attribute is CD. And what I want to do is, let me just come to this point. Okay, so what I want is, let's take both of these to be black. I want to add a point in the middle. Yeah. And make this blue as well. Okay, so yeah, just sort of like, something moves through the middle of this. And again, let's take this and make it about 3. Yeah, so it sort of gets like a glow. Actually, yeah, let's keep this like that. Yeah, I think this is okay. Okay, so this is good. Now what I want is I don't want all of these to turn into trails. I just want some of them to turn into trails. Okay, so I can take a delete and delete points, and we'll do delete by range. And I want to delete, or we can delete by ID as well. Okay, so what I can do is, you can try it here as well. So I can do, say, let's try 9 of every 10. Okay, so we just have these many. Okay, so which isn't bad either. But if you want it better, then we can just do by expression, and I can randomize the ID. So do random at ID, and let's try less than 0.9. Yeah. So I think these are, this many is good enough. Okay, so now in order to generate trails out of this, you can just take a trail sop. This is slightly slow to calculate. Okay, but there are other ways to do this. This is the easiest. Okay, we can take the trail length to about like 9 or 10. Okay, and then take an add, and what happens is, like, each particle has a unique ID. And when you generate a trail, each one of these points will also get the same ID. So we can connect them based on the ID number. Okay, so come to polygon in the add sop, go to by group, change it to attribute, and just type in ID. And there you go. So you'll get this. And let's say we want to recolor them based on the length. So I can take a resample. Okay, let's resample these. We'll say subdivision curves. And within the resample, just generate the curve view attribute. And then take a color. And we can set this to ramp from attribute curve view. And there you go. So you can, color them based on length. And what I can do is I can just reverse this. And the same coloring. So I can actually, let's just do Control C, Control V over here. I'll plug this in and just change this to curve view. There you go. Yeah, I think this is good. So we'll get, these guys sort of flowing outwards like that. If you want longer trails, we can increase this. So let's say if I make it 15, see, so you'll get longer trails. And so I can merge all of it together, and that's pretty much it. So if I take a merge, see, so I have some particles and some trails, And what I can do is I can press D and we can make the particle size a little smaller. So there you go. So as it breaks out, you'll get some of them, and then we can merge it into the final thing. What I can do is, once we merge all of it together, you might get some issues because I think the particles have normals and this doesn't. So just take an attribute delete after this, and we can delete pretty much everything except the color. Okay, so in point attributes, type in star and then do an uptick and CD. So we want to keep color and we want to delete everything else. And there you go. So there you go, you get like, something fancy. Okay, now here is a very small piece of homework that you can do later. Is in the visualization, in the disintegration that I did, you can see like it moves a little bit like circuit lines. Now, this is from an Entagma tutorial, which is technically just adding 2 nodes, like that's it, in your volume warp. Okay, now I won't show you what those 2 nodes are. Like you need to add them here, like at your curl noise. I'll show you what the tutorial is. Yeah, so if you go to entagma.com and on the second page of the free tutorials, you'll find something called as modifying curl noise. Okay, which basically shows you how to turn curl noise into like circuit lines. Okay, as I said, it's a 3-minute tutorial and it takes only 2 nodes. So I won't repeat that because it's already there, and you might as well see their work because it's phenomenal. But yeah, if you want to change this basic emission into something more fancy like circuit lines, you can just follow their tutorial and do that. Okay, so that's your homework. Alright, so that's basically it. So this is the new disintegration tutorial. Hopefully this should last for another 4 or 5 years before I have to update it again. But yeah, I wanted to cover or add in a few more things. Primarily how to make custom velocity, because that's always useful. Yeah, so that's pretty much it. So as I said, I'm going to try and upgrade or update more of my older tutorials, maybe some of my older trainings as well, but we'll see how that goes. Okay, so as usual, if you have any questions about this, you can ask me in the comment section. You can write to me via email or Instagram, Twitter, whatever. Yeah, and that's basically it.